Hi, my name is Jason, and this is the Pattern to Print channel. And today I'm going to be talking about a new, really exciting technique called velocity painting. Now, velocity painting was come up with a few months ago by a guy named Mark Wheadon, and he developed this technique to take STL files, and then by altering the speed at which the extruder goes around, it can create images. So, for example, I have this little cylinder here, and you can see it has a pattern in it, and that pattern was put in there by altering the extrusion speed as the printer head went around. Now, when he first came out with it, to use it, you really needed to be pretty tech savvy to be able to take his scripts, and because what it does is it takes G code that you have from the model without the painting on it, and then sort of superimposes the speed changes. So a few weeks ago, he partnered up with someone, and I'll put his name down below because I'm afraid to pronounce it, and his Twitter handle, to create a front end for it with a GUI, and that came out, and it came a new version of it came out a few days ago, and I've been playing with it, and in this episode I'm gonna go through how to use this user interface so that you too can create some of these really cool prints.
All right, so to use the software, of course, first you need to get it. So the website to get the download, what that's being hosted is this velocitypainting.webutu.com. And this is the homepage, and it just talks about the concept a little bit. And then to download, you click the download page, and they're very nice, and they offer all sorts of versions, both for the Mac and for Windows, and if you have a 32-bit or 64-bit. And as they're improving it, if you found a previous version worked better, then you can always go back to a previous one. And they also have a donate button, and I would really encourage you to encourage them to continue doing the work on this. They put in a lot of time, and they're very responsive. I had the reason for the 5.1 is I noticed that the cylinder print mode didn't work, and they fixed it within a few hours. So definitely support them. And then once you download it, for Windows it's an exe. For Mac it's just a just an application. You double click on it, it'll work. I dumped it into my application folder just so I can you know get it easily with my other programs. And then they have a short little manual here. I found that for the most part it was good enough. There's a couple kind of things that I wasn't quite sure about, but it pretty much got me through to everything that I needed to know to get good output. So definitely read through and all of the all of this content. And there really isn't a ton here, so it really shouldn't take you too long to do that. So I've got it here. The program itself, it's very simple. So to run something, first you need to select the G code. Now, to select the G code, first you have needed to create it. And so what I used for this go about was a slicer. And there's a very particular way you need to set your settings. The way the program works is it essentially rewrites all the speeds in your file. So it doesn't really matter what speed you set the print speed at, but it has to be the whole print outside the first couple layers where you want to have a good bed adhesion and where you're not really going to be running this process anyways. You want it at the same speed, and you don't want anything set like, hey, I've got a really thin tower, slow down. All that needs to be turned off. Inner parameters, outer parameters, everything needs to be the same. Now, like I said, it doesn't really matter what that speed is set at, but you probably want to make it a reasonable speed within your printer in case you mess something up and you don't want to set that you're going 1,000 millimeters per second. Your printer will not be happy if it doesn't work out. So, for example, for some of the settings that you would need to do, layer height, basically the thinner your layers are, the more resolution your image is going to have. So that's also kind of dependent on, how thick your nozzle is and all that kind of stuff. Infill, again, the standard, like I'm doing, kind of doing vases and stuff. If you're taking a solid model, you want to turn into a vase, you want to, take out all the infill and the roofs and stuff like that. But that's kind of independent of this process. You can have a skirt and a brim. That's certainly fine. Um, Support materials. If you need support materials, it probably doesn't matter whether this impact has on that. So speed is where you really want to pay attention. And notice here that I've set everything to 60 millimeters per second. And again, it's not really critical what this speed is. It's just that it has to be consistent because it's going to be overwritten. And the other caveat is you don't want it set to the speed that your first layer is going to be when you print, because if you have it as the same speed as that speed will also be rewritten, and you're not going to get good results there. So your first layer speed can be different. That's fine. In fact, you want it to be different rather than everything needs to be same. Your travel speed, since it is an actual print, a printing thing, that can be its normal standard self. Everything else, the critical things is the speed. The filament settings, again, just do what you would normally do. Make sure you've got your filament measured correctly and all that. And yeah, everything else is pretty much the same. So it's your speed settings. Oops. It's your speed settings that are critical to get exactly the same. And whatever, I mean, so you don't need to use Slicer. You can use just about any slicing program, but it's these speeds that you need to have the same. So once you have those speeds set, slice and export that G-code, and that's going to be the G-code that you're going to transform using the velocity painting program. So when you select your G-code, I've got a whole bunch of G-codes that I was trying out. This is what you're gonna use. And then the second part of this is you need to have an image that you're gonna impose on this. Now you can do all sorts of things with images. In general, it's going to be, if you have a color image, it's going to be converted to a grayscale. So you might want to convert it to a grayscale yourself to see how it's going to react. Now, what I use in these early tests is I used basically black and white. This is the one I use for most of the tests. It's a Celtic knot pattern from the Celtic knot font. So it's kind of a square, and you can see it's black or it's white. I also did a silhouette of my daughter real quick, and again, it's black and it's white. Now you can use gray, just that it's going to be a little different, and I haven't experimented too much with that. So in the select image, you want to make sure you go select the image and do that. Profile, you can set up different profiles and save them and load them for later if you want to use them. Printer coordinates. Now this is really a critical thing. I'm running this on a MakerBot replicator clone, and MakerBots tend to have the center of the build plate be 0, 0. Now that's not typical. A typical would be like, say, if you have a build plate of 200 millimeters by 200 millimeters, that the center coordinates would be 100, 100. So check how your printer's set up, check what the center is, and when you load the model, make sure it's in the center of the plate, and then make sure you have the correct center coordinates in here, and that's really critical. Here we have the print speeds. Now the target, this is what you put in your program. So I put 60 millimeters per second. Well, that translates to 3,600 millimeters per minute. So this, every time, what the program's going to do is every time it sees that 3,600 in the G-code file, it's going to rewrite it based on the based on what it has in the image. So this has to match, or nothing's going to happen. If you have this as a different value, your model won't be changed at all. Then the next two values are how fast you want it to print when it's at the low end and then when it's at the high end. So we have two different things you have to keep a track of. First of all, notice that I have the target and the high set the same. They're completely unrelated. You don't have to do that. Again, the target can be whatever it wants. The recommendation here is that this ratio should be at least 2 to 1, so that your high speed should be twice as fast as your low speed, and if you can, have it to be 3 to 1. Now, when I did my first print, I basically had 90 millimeters per second and 30, so 90 is the high, 30 is the low. I found 90 was a little fast. It was, some of the filament was kind of breaking a little bit. Not bad, but it was struggling a little bit. So then I kind of did 60-20, and it worked pretty well. And I saw on one of the Twitter posts from Mark that he did like, I think 10 and 30. So that was pretty slow speeds, and it came out really well. So to get the image, the critical thing is the ratio between the high and the low, and then it's just basically how fast can your printer handle and whatnot. It says how high you want that high to be, and then getting a third of that for the low. Now with the we have several different paint types, and so this is how the image is going to be put into the print. So the projection X is that, imagine the X-axis being a wall. So that the image is going to be projected straight on that wall. So for example, most of the testing I did with cylinders. So I'm using, even though I used Slicer as my slicing program, and the reason why I did that is I was having some issues with Simplify 3D and the converting to the Sailfish firmware format because of the workflow. But Simplify 3D has a great viewer. So I'm going to preview my first one. So here we have the X projection. So it goes all the way through. So if we look at, this is the front, and since this is a symmetric picture, it's going to look the same front or back, but this is going to be the mirror image of it if you looked at it once you printed it out. Also notice is that since the cylinder isn't flat, it's not real dramatic, but as you get out towards the edges, there is a little bit of kind of stretching as it goes around the corner. So if you're doing an X projection and you're projecting at something that isn't flat, you are going to get kind of a warping on the sides. And that's just sort of an artifact of how this technique works. So that's an X projection, and then we have the Y projection. And I will load that up, and that I know I moved. I'm pretty sure I moved that to where the other ones were. Okay, so the X projection and the Y projection are actually exactly the same, except it's just rotated. Now, in general, there probably isn't, if you were having a model, you could rotate the model and you always use X, but there could be a use case for using Y, and in fact, I might use it myself, is that I can in Slicer set the, where the zipper is sort of where it changes to the next row, and you can set it, and you can set it in the back. So if you have this sort of this blemish in the print, you can set it where it isn't going to be seen, instead of having it be like in the middle here. So, but again, it's the exact same as the X. You sort of get the same sort of warping on the edges when you're doing it on a curved surface. Now the next one is quite a bit different, and that's the Z projection. And that's going to be straight up from the top. And here you see that there isn't any warping because it is projected on a flat surface. You also see quite well that these projections go all the way through the model. So if you had a solid model, it would, these speed changes would go through the entire model. Now with these, and let me bring back the one of the Y for a moment to illustrate this a little better. In the choices, you have this image details, and you have height and Z offset and width. The Z offset is how high off you want the image. So here I wanted it 3 millimeters off from the floor. So that wasn't really high, but it was a little something. And then I chose 45 for the height. So you have the image, and I wanted it 45 millimeters high because the cylinder is 50 millimeters high. So I figured 3 on the bottom, 2 on the top, and that would be pretty good. If you want the width to be proportional to the height, then you just put a dash and it'll make the width so it maintains its proportion. Now you can override that and you can stretch or shrink the width however you want. And these work for these three main projections, the X, Y, and the Z. Now for the cylinder, it's a little bit different in that you need to, with the cylinder, it's going to choose the width. So you have to take out the value for the width. If you put anything there, it's not going to take it. It's going to give you an error. And so to look at what the cylinder does, first I'm going to do the cylinder with this base image that I've been using before. And so this is it. And notice it takes that image and just stretches it all the way around. And that's what the cylinder does. So that's why it doesn't allow you to put in a width, because it'll just take the height and then it'll just stretch it all the way around. Now, this doesn't look very good. So what I did is I loaded up a different image. So this is the image that I went with second, because this is a lot more proportional to what a cylinder is going to have, the height and weight ratio. So loading up that one, and see why. Now we see that it is it looks a lot better because that width was more proportional to the height in the original image. Now something to note here is that there isn't that, besides the stretching or whatever, since you're projecting it on a cylinder, you're projecting the cylinder feature on a cylinder, there is no proportional stretching from one place to another. It's all exactly the same. And to sort of illustrate that, if we have a cube, then we get distortion again because it wasn't designed, a cylinder stretched on a cube is going to warp a bit. And let me see if I can quickly pull that one up. I think it was this one. Okay, so now we have it on a cube, and now the effect isn't really dramatic, but if you look, the edges are thicker than the center. So as the corners pull further away from the center, the image gets stretched out more. So it's just something to keep in mind when you're putting these things together. Now the final option that you can do is spherical, and I have to admit I don't quite know how this works. I've put a couple things in it. I'm gonna have to do a lot more testing to see what exactly it's doing to the image, but to kind of give you an idea of what it looks like. So this is with my original image, and I'm gonna preview it, and I think it was this one. And this is what it comes out as. And I can't figure out, I mean, I can sort of see how my original image, if you look at here, you can kind of see that this matches up with the center, but I really don't know how the projection works on this one. So I'm gonna do some testing with it. It's kind of interesting. Once I figure it out, you can probably make some pretty cool Christmas ornaments out of this. So like I said, I'll work that one out, puzzle that one out a bit more later. So I've explained the offsets, and then basically once you've set all the settings, all you do is hit the generate button. Oops, I'm in the spherical. I'm going to go back to the normal ones. You hit generate, and then you save a name, and then that gives you your velocity painting file. And then as the instructions are very specific. Once you create that file, you definitely want to preview it in a viewer so you know that the results are what you're expecting, that, that it did do what it was supposed to do. Even with that, though, they do warn you that this is still a bit experimental, and you know, they're not responsible if anything funky happens to your machine. And this is also something that if you just got a brand new printer, maybe this is something you don't want to do your second or third print. This is something that you probably want to get a little bit of experience in first before you tackle something like this, because you have to have kind of an understanding of what's going on, um, so you don't do anything really strange. So now what I'm going to do is I'm going to have a short video where it's actually showing the velocity painting. I keep on crossing that up in my head as it's doing it. Because the printing is definitely different than what you normally see your printer doing, and this is just like, okay, this is okay, it's not a problem. And then I've got a time lapse of the one with my daughter. So that's coming right up. I wanted to capture a few seconds of watching it as it's printing. As you can see, as it gets to where it's painting on it, it kind of goes through speed ups and slowdowns, and that's what gets the image into the actual print. So when your printer kind of makes these weird noises, it means it's actually working on this instead of it's kind of wigging out. I hope that tutorial was enough to get you going on this really neat technique. Like I said, it's something you have to pay attention to the details, but if you do, it's really not that hard to get these really cool results in these prints. And it's something I've just been playing with for a few days, and I'm sure I'm going to learn more as I go on, and I may do some more videos on this as I cover some more techniques with how it works. So if you have any questions about anything in this tutorial, please leave the comments and I will answer them as best I can. If you like the video, give it a thumbs up. If you want to subscribe to find out more about the things that I talk about in these tutorials, be sure to click the clock. And that's it for this time. Thanks for stopping by and have fun printing.